Hello, this is part 2 of the lecture on RCTs, or Randomized Controlled Trials, as part of the QED module. In the first part I was talking about experimental designs, and I got to the stage where there is a problem with experimental designs, which is that in social science we often want to isolate the effect of one particular factor, for example school toilets, but unfortunately at the same time there are all kinds of other factors that could also be having an effect, and it's very hard to isolate the effect of one factor. So one very widely used solution to this is randomized controlled trials, which we talk about now. And the basis of randomized controlled trials is quite simple. It's randomization. So in any randomized controlled trial, the groups are formed by randomly allocating individuals to groups. So the idea is you have these schools with their combination of all these factors. For each one you throw a dice or use a computer, usually more often, to allocate some schools to A and some schools to B. And when it says randomly, it doesn't mean someone just chooses. That means you really do use a computer or a dice or drawing names of schools from a hat, something totally immune to influence by human subjectivity. That's what we mean by randomly. Now, the idea is that once you've done that, you've got groups in school A and school B, then if the allocation to groups is truly random, then each of these groups should have a similar range of values for each factor because they've been randomly chosen. So the range of wealth should be similar, range of occupations should be similar, and so on. So if they're similar, then the effects of each factor should be broadly similar, which means that if you find a substantial difference here, it must be due to the effects of the toilets alone. Now, before you start celebrating, there's a further problem, which is Unkns. Now, above I showed all the factors I could think of, and I asked you to think of your own factors beyond this. The problem is, these factors here, and the ones you might have added, they're known unknowns. So we know that there's something called distance from school, and we know that we don't know what the effect of that is. We know we don't know the effect of wealth. We know we don't know the effect of employment availability. But at least we can put some label here and think that no, there's something here we need to measure or estimate. But there could be other things which are completely unknown factors. So unknown factors with unknown effects, they're called unknown unknowns, or sometimes Unkns, a slightly ugly phrase used in the statistics jargon. So what can we do about Unkns? Well, the short answer is we don't have to do anything, because even if there are other unknown factors, then the randomization should still equalize the effects of it between the two groups. So the claim is that RCTs can deal with all these factors, the known unknowns and the Unkns too. Now in RCT notation, this is how you show a randomized controlled trial. It looks very similar to the previous one, except here, instead of officials putting things into groups, the essential thing is you must have a random allocation. As you'll see in practice, in virtually all the examples I can think of, and certainly all the ones we'll be looking at, you also throw in an observation beforehand. Yeah. So you put an O here and here. Okay, so 2 examples of actual RCT research will follow in the next clip. Thanks for watching.